concept of communication is just really important to me. As you guys know, I'm writing this book called The Art of Extreme Speech. And so I'm going to have to share another time because I'm thinking that what I really need to do is test the outline and premise of that book with you guys and have you pick the thing apart and make me look really stupid. So I'm looking forward to that at some point. But when I left the call last time, I told you my brain was blown out over this whole concept of this relationship or these ratios of pi and phi. I guess phi is phi in some places. In England, I think they call it phi. But or maybe in Australia too, eh, Kelly? Anyway,
no, it's pi here.
Is pi here? So, well, I had a big debate over two Christmases ago in my family. We ended up Wikipediaing it at our Christmas dinner to determine how phi was actually pronounced. And so I decided to go down that route. And so what I have here are just some things I found. And I'm really not sure which one I want to show first. The guy that I found, you guys know Charles Gilchrist? I'm hoping that you don't know Charles Gilchrist. He's Susan's nodding her head.
Well, I think the name sounds vaguely familiar.
Yeah, well, he's a sacred geometry guy. And literally, I spent 10 hours looking for these videos and came up with this guy last night, which I thought was profound. So we'll start with this, but I've got another dude here. This guy is, oh crap, I don't even have his name, but he's Math Logger. And wait till we see all these vectors. It's going to be very, very exciting. And there's a relationship between, this guy shows the inner workings of math in the Mandelbrot set. And so this is going to be an exciting thing. What it pertains to, I'm not sure. I'm going to let you guys figure it out and tell me what I'm watching, okay? But to start, let's start out with this guy. And I think I'm going to start out with the answer first, even though I thought of building into it. I don't run out of time. So here we go. And I think that this guy can be, I want to come over here to my, before I start, I want to come over to my settings and I want to share, and I want to share computer sound. And there we go. And so this is all left over from last night. And now I'm wondering if this thing is going to take forever to boot or what. Okay, there we go. Okay, that's looking a little bit better. So I'm not there's a lot of dogma with sacred geometry in these mystery schools, and I'm going to cut this guy off at one point. Okay, we got some audio. This guy we can do it 1.5.
Now we're going to talk about the fantastic relationship between pi, phi, and Fibonacci sequence. And it all has to do with dimensionality. The dimensions. The first dimension, the second dimension, the third dimension, the fourth dimension. So what is the first dimension? In sacred geometry, the first dimension is expressed as a single point. This isn't a point that's in relationship to other points. This is a point beyond everything else. This is the point that's everywhere and nowhere. The center of everything. You and I and the sun and a distant galaxy, each of those centers is the same center.
Okay.
Here we are. We live in this three-dimensional universe.
So this is important to me because I do this thing on Native American spirituality. And most of the time when people study Native American spirituality, it's all about the cardinal directions, the 4 cardinal directions, north, south, east, and west, and about the helpers and the guides that come from those directions. So in the east is the eagle, and in the south is the wolf, and in the west is the bear, and in the north is the buffalo for the Lakota. And different tribes have different, and different clans have different animal helpers that come from these directions to give their clans energy. I was in Native American spirituality for 10 or 15 years before I heard about the 7 directions, but it was always about the 4 directions in the medicine wheel. That center point in Native American spirituality, that is the 7th direction. And my medicine, you guys, I was blessed as a Native American medicine, as an Okava Native American Church medicine person in January of 2018. And my medicine is meditation, and not meditation, but awareness. And so I teach people how to breathe and how to go in and find the seventh direction. In fact, we're talking about creating little meditation lodges that are preparatory to doing Vision Quest. And the key is to move into this seventh direction. And that, I think that's really important here. He's talking about the center point. And I actually got some new awareness by this guy's conversation. So I'm going to repeat that part again. Here we go.
The center of everything. You and I and the sun and a distant galaxy, each of those centers is the same center. Here we are. We live in this three-dimensional universe. And yet there's a two-dimensional universe and a one-dimensional universe. This painting here, this is a three-dimensional object, just like we are. And yet, it's illustrating two-dimensional conceptual idea. 4 circles of common radius. The Vesica Piscis. The petal. These are purely conceptual two-dimensional ideas, and yet they're represented on this three-dimensional surface. But the real abstract thing that we're trying to start from is this idea of single-pointedness, which is beyond three-dimensional reality, beyond two-dimensional reality, underneath, inside of it, one-dimensional reality. So in the language of sacred geometry, the single point precedes creation, and it's the division of the single point which creates vibration. And that's what the universe is, vibration. Everything is vibrating. The root motion of the universe is expressed in the radius and the arc, the two energies that happen between these two fantastic points, the single pointedness, this unity, this oneness, which divides and becomes duality, voila, energy, motion. It's like...
Okay, so I went and I found this other guy that I won't play the video for, but I took some pictures because I think it's really important. Because the definition of a circle, I'd forgotten what the definition of a circle was. A circle is a set of all points that are equidistant from another point. So in this guy's video about a circle, he starts with a point here in the center, sets up another point equidistant apart, and then continues to do other points that are equidistant from the other, and ends up with a circle. And
another point, this is in a plane, in a
two-dimensional plane. Mm-hmm. So you could imagine this being in a three-dimensional plane. It's harder to imagine that in a four-dimensional plane. And if we have time, I'm going to show you this great video I found on four-dimensional reality. It's a video game. It's absolutely kick butt. So I had never known this. I hadn't been aware of this for too many years. So I thought that was really important. And the fact that he started with 2 dots, and the fact that there are 2 dots here, and there's a relationship of these dots to create the circle is really cool. And then, so pi is the ratio of 2 different distances in a circle. The distance around the circle and the distance across the circle. And I found another guy who did a great video showing, and I never thought of this too, because I know that pi is 3.14159, blah, 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 right? But he said, hey, pi is almost 3. It's a little bit more than 3. So it takes 3 diameters to go. If I took that diameter, if I had a string that size, and I started at this point and started wrapping the circle, it would go 3 times and have a little bit left over. So if I have a 30-foot diameter circle, then I have a 90-plus circumference in my circle. And I'd never understood that. Basically, I'd always take out a calculator and go 3.14159, right? But it's just a little bit more than 3. And I thought that was pretty cool. And then for some reason though, I learned pi as a radius instead of as a diameter. But anyway, I thought that was kind of interesting. So there's the definition of a circle. I thought that was kind of cool. And now we'll go back to this thing. If anybody wants to interrupt me, please feel free. Here we go.
Vibration. Everything is vibrating. The root motion of the universe is expressed in the radius and the arc, the 2 energies that happen between these 2 fantastic points, this single pointedness, this unity, this oneness, which divides and becomes duality, voila, energy, motion. It's like the equivalent of yin-yang, the twin energies at the root of the universe.
That's a cool video.
Now,
have you guys seen yin-yang over the flower of life before? You guys
No.
recognize this? This is the flower of life, and I hadn't seen yin yang drawn on that. I put yin yang on top of everything. I even have it on the medicine wheel, the Native American medicine wheel, showing the relationship between the north direction and the south direction. And then I flip the yin yang over and show the relationship between the east direction and the west direction, saying that, and maybe we could talk about that briefly, that the east direction is yin and yang of the west. And the west is, of course, the cave and introspection and coming out of the cave and the nightmare and death and rebirth. And the east is the new idea, the child. The west is the adult, and the east is the child, the infant, the new idea, the birth of the new idea. And without coming out of the cave, there is no new idea. And without the new idea, there's no coming out of the cave. The east and west are yin and yang of each other, and I thought this was pretty cool. So I hadn't seen it with a flower.
If you hold the motion between 2 points to a given distance, and you let this energy happen, this spinning energy happen from the radius and the arc, it creates a circle, and we have pi. If you take the same energy, the same spinning, counter-rotational spinning energy that happens between the 2 points, and you don't limit the distance between those 2 points,
Okay.
you have the spiral.
This was mind-blowing for me, because after doing, really literally going through 30 different videos, nobody ever said what the exact, because when my mind was blown last week, it was on pi and phi. And now I get it. And I thought you guys would like this, because you're always talking about inside and outside, right? So somehow pi has an inside and outside, and phi continues to expand from the inside to the outside. And maybe I should let you hear that again so that you guys can critique that from your perspective.
You have pi. If you take the same energy, the same spinning, counter-rotational spinning energy that happens between the 2 points, and you don't limit the distance between those 2 points, you have the spiral, phi. So this energy, this root energy of the universe, from one perspective creates a circle,
So that
from
guy's a
another
genius,
perspective
because
creates
that
spiral.
circle was almost perfect. Did you notice that? That blew me away. I don't know. Guys who can draw a circle.
Between those 2 points, you have the spiral, phi. So this energy, this root energy of the universe, from one perspective creates a circle, from another perspective creates spiral, phi and pi. Pi and phi are really brothers
Or
of the
system.
same energy, different ways of looking at the same energy. And that brings us to the Fibonacci sequence. The Fibonacci sequence, principally thought of as a growing sequence, was discovered by the brilliant medieval Italian mathematician Leonardo Pisano. Yes, that's the same Leonardo Pisano who discovered the famous 2D
Hey, do you
graphic
guys
known as
know
Metatron's cube.
Are you guys familiar with Metatron? Susan's nodding her head. Of course, she knows it. But this Metatron's cube, this thing is amazing. So, and we're going to see how amazing it is. And this guy explains it better than most people.
Leonardo discovered that a type of plant he was observing would first grow one leaf, and
Yeah, just okay. Maybe I have to wait. Just
Okay.
continue.
All right, because this is pretty good.
discovered the famous 2D graphic known as Metatron's cube. Leonardo discovered that a type of plant he was observing would first grow one leaf, and then one more leaf, and then two more, and then 3, and 5, and 8, and on and on. Leonardo went on to discover that this was not an isolated phenomena, but rather was observable in countless cases throughout nature. But for me, the most significant aspect of the Fibonacci sequence is the fact that the proportions of the couplet numbers quickly approaches phi. And the further up you go, the closer the numbers comes to phi, until there is virtually no practical difference. This proves that Mother Nature is following this root principle of sacred geometry in the growth of the universe. So inside this multi-dimensional universe of ours, we have this unity reality, this oneness, this single-pointedness, inside the two-dimensional reality, the conceptual reality, which includes pi and phi, and then we have the three-dimensional universe unfolding out of that. This is a dodecahedron, pentagons, which springs out of this two-dimensional conceptual world. And that is the nature of the universe. Everything springs from oneness. And then we have conceptual two-ness, two-dimensional reality. Then we have three-dimensional reality. And that's where the phi ratio interacts between the two-dimensional world and the three-dimensional world. And when it comes into the three-dimensional world, it becomes the Fibonacci sequence. Something tangible, like 8 and 13, a solid rational number. That is really interesting. Very interesting. So in between these worlds, in between these dimensional worlds, this one-dimensional world, this two-dimensional world, this three-dimensional world, and this fourth-dimensional world, there's slightly different rules for each of those realms. And when the adjustments happen, when the changes happen in between these planes, the rules get slightly shifted in between those planes. For instance, this painting back here, this is a representation of the phi ratio, which is an irrational number and doesn't resolve in a concrete way. And yet this painting has a
I
convention.
just want to say that I got clear because Kelly says he doesn't get irrational numbers. I got clear on a simple definition of an irrational number. Maybe you guys know this, but an irrational number cannot be expressed in a fraction because it cannot be expressed accurately in a fraction, and because it doesn't ever resolve, it just keeps going. And I don't know if you guys knew that, but I got that in this study, and I'm grateful for, now I can say what an irrational number is. At least I'm satisfied with that definition. Let's let this play a little bit further. I can see. So
here's the thing. It's representing the phi ratio, but it's actually a Fibonacci sequence number here. This number here against this number here would actually come out to be a Fibonacci number. Huh? This is a dodecahedron. It's one of the 5 platonic solids. It's a 3-dimensional representation of perfection, of a perfect principle of the universe. And anywhere in this universe where there is a sentient life, they will come to these ideas of geometry. They will find a dodecahedron. They can't help but find a dodecahedron because it transcends time. It's space which transcends time. And at the center of this dodecahedron, there is single pointedness right in the center of this thing, just like it's the same center that I have. It's the same center as this dodecahedron. And it's your center too. And it's like Wavy Gravy said, no matter where you go, there you are.
okay, here we go.
We live in this 3-dimensional universe. We breathe in it. We have our life in it. We have our being in it. We experience time and space in these bodies. And yet, there is a oneness about us. It's an illusion on one level. It's an illusion that I'm a separate entity from you. We are one. We are single point. We are the same single point. And the principles behind this universe are so perfect and so beautiful
He gets a
and so
little
inspiring that it points towards a creative reality behind everything.
Okay, here we go.
So this whole Sacred Geometry 101 series started with single point, and it's evolved and progressed, and it's right back to the same single point. I honor that single point,
Oh, crap.
and all I can say is namaste.
Oh,
Namaste. The oneness and the single pointedness and the spirit within me recognizes the oneness and the spirit within you.
okay, I got to show you the other video to get to the other part. I thought it was going to continue on. We'll pause right there and open for feedback.
Whoa. Okay. I have so many things. I put some stuff on the chat box, in the chat box.
Okay,
Yes, but
I'm sorry. Okay, there we go.
One-dimensional
good.
universe. This painting here, this is a 3-dimensional object.
Okay, we started over again. Okay, he's done. I'm looking at the chat box. Go ahead, Manu.
okay, so I first start with pi, 2-dimension, and the circle. And I try to link it to what we've been seeing, boundary, right?
Right.
The circle is a boundary. And the diameter is a number. It is measured, it's a feedback. And you
Right.
say something here is that when you take diameter, first it comes from experience, right? Where we fix something in the center, and then we try to walk around, keeping the distance to the center, let's say a rope to make a circle. But let's take that diameter that we can measure, right? An integer, and then we try to superimpose it to that circle that we conceptually trace. There's always going to be a leftover. So to me, boundary from inside your universe with numbers, integers, you are measuring. And you are measuring, there's always something left over. That's the part, that's always, whatever circumvolution that you take is always going to be left over in terms of that ratio. So that is the first thing that I see. Is some kind of quasi duality, but lag. I don't know how to express it. The second thing that you say is the phi. And I made the comment there that in quantum mechanics, you heard about the Schrodinger's equation that allows you to find quantum positions of particles, right? And he calls it, I never understood why he called it phi, but the function in mathematics is always called phi, the phi function. And you come in here with the notion of vibration, that is amplitude and frequency that you talk about. And that vibration, especially in, you are within a universe and you have a multiplication by the division, you're gonna have some patterns, right? And those patterns, to me, is a flow, but the flow that is orderly in such a way that you can see things. I call it a steady state of flows. And those are also irrational numbers. It's only ideas that I throw in like that. I don't know what you guys think.
What was the last thing that you said? It's only
A
divisible.
steady, I say it's ideas that I throw in. You know, like it's not tested anywhere, but I feel like a pattern. Let's say color, yellow, is a chromatographic pattern. And that pattern is irrational. It will be represented by something irrational. Because it's an adjustment of flows of different particles in a way that they are in some kind of dance. It's a pattern, right? So
Okay.
everybody's like pensive there. What do you feel?
What do I think? I'm skirting. I feel like a new kid riding a bicycle. So I have thought about Schrodinger's equation. I've thought about the relationships you're talking about, and I'm not sure what to think at this point. So
Okay, let's just take it like this. How do you explain the Gulf Stream of the current of Benguela here in Southern Africa, in the middle of the turbulent ocean? The Gulf Stream flowing from the Gulf of Mexico up to Northwest Europe is some kind of steady, isn't it? It is something that is very identifiable, and the effect of it can be measured. It's not steady. So in that environment, the Gulf Stream is a pattern.
gotcha.
And in the world of numbers and ratio of things in the universe, that's the way it goes. To me, an irrational number cannot be expressed as an integer. It cannot be expressed as a fraction of two integers. It can only be expressed as the relationship of
Right.
things in motion in a steady state.
I agree with you. An irrational number describes a ratio, and that ratio is continuous and flowing,
Yes.
and it shows the relationship. I'm having trouble with my computer. Okay, good. I got my thing to stop. So I got it. So are you complete, Manu?
Yes, that's what I'm saying. You know, the pi, the phi, the summation or whatever, you know, the signs, and then the infinite sign and all these things are ratios. And you can count. You don't know what asymptotic relationships are in geometry. You have a plane, and something approaches the plane without ever being able, always getting closer, but ever being able to touch that plane. It's called an exponential with certain ratio. It's always going like that, and never like 1/3, for example, or those things. That relationship is, and in patterns, in fractals or whatever, is what I would call irrational.
Okay. I agree.
I've only got one question.
Yeah.
Show me in nature where you'll find a perfect circle.
Yeah, that's the other issue. Show me in nature where I'll find a perfect line. Those
Yeah,
things are, they are
so
mechanisms of the brain. Go ahead.
they're not mechanisms of the brain. They're a mechanism of the mind.
Okay.
Because we have this experience. So all of a sudden you have this vibration. And each one of us starts where we're at with that vibration, right? Where I'm at. My experience of that vibration.
Right.
Okay. And so somebody's been clever enough to say, well, if we look at a circle, everything's got a circle. But when you draw those points, we end up with this concept of a perfect circle.
Right.
And then we get patterns of behaviors and vibrations and that. So I don't think you've got a constructive nature. I think you've got constructive mind and language.
Yeah.
And the sooner we come to terms with that and get rid of this asinine thought, you know, it's a spherical spiral overlap. It's not a circle with a line. You understand my point?
Yes.
It's like when you're looking at
Is that a pun, Kelly?
What's that?
You said, we got to get over circle and line. Do you see my point? I thought that was quite a pun. That was pretty.
Okay, well, there you go. Pick me up on my puns.
So spherical, spiral, overlapping.
Yeah. So it's a continuous.
Right.
It's a continuous sphere that has a spiral, and the spiral's going in and out. And so Fibonacci, I studied Fibonacci for business, right? And I placed the patterns in my mind to suit a business, the startup of a business. And I could only get it to fit into a business to about 55. And then once you go from that, it starts to repeat itself in the business sense. So now I'm looking at its regenerative process. Because in my mind, we have an experience, a mind relationship, and the mind relationship is looking at the physical relationship as it relates at that moment in time to that wherever I'm at right now. So I always believe you start where you're at. And so we got pi, phi, circles and vectors, and those are just mind relationships, so we can describe them. And when you see this drawing, you know, the drawing looks beautiful, but I don't know, you know, in nature you've got these beautiful things, but I don't know that you're ever going to get a perfect circle or a perfect line.
Agreed. It's a figment of our imaginations. It's just a way a finite brain describes something that's undescribable.
Yeah, or it's described in a way that we can pass on information. Yeah, if you look at there, exactly the point.
Yeah, I thought you would really love this because you were talking about this spiral that I want to describe as a circle with a diameter. In fact, that looks like a Native American medicine wheel right there in the middle with the north, the south, the east, and the west. It's broken up into quadrants. But the actuality is everything is in constant motion in relationship to itself.
Yeah.
And my little brain, my little mind says, okay, I want to understand what the hell is going on, so I do that to it.
Yeah, and in my mind, it's not a circle.
Yeah.
Spiral.
It cannot be a circle, because while doing that, it's always bombarded with something. In reality, it always collides. They are always overlapping. They are always interacting, and you always have impact. Action, reaction, and resultant from all those.
Right on.
Yeah, you got action, reaction, resultant, regenerated.
Yes.
Yeah.
The second you leave off regenerative, it makes it sound like it just finishes at result. It doesn't finish at result.
It doesn't ever finish.
It doesn't ever finish. And so what it actually becomes is a regenerative vibration is what I'm hearing. So it says, okay, I've got this point, it starts to vibrate.
Yeah.
And now when it starts to vibrate, you then have, we conceive of these boundaries because we can't see the boundaries. Like if we look in the ocean, the thing that you got to look at is the thermos and the densities.
Yeah.
So Manu, when you're talking about the ocean, you say, how do you describe that? Well, you've got to talk about heat differentials, the temperature of the water to whatever else is going on, the wind, the thermos, and everything else. And at that moment, it becomes very hard for us to understand. I mean, what's going on in the Amazon, now all of a sudden, we're starting to get people to get concerned about the fires, which we've had forever. So that to me is an increased awareness in a global vibration. But it doesn't solve the problem. It's just, okay, you're aware. And now are you conscious? Anyway, that's my 2 bits worth.
So I want to show you one more thing. I could go into another video here with this guy where he takes the Metatron's cube and he goes through all 5 platonic solids and shows how they're demonstrated in this Metatron cube shape. But we only have a few minutes left, and I just got to show you all these vectors. I found this thing that just blew me freaking away. This is one of the first things I found, and I was basically hypnotized by it. And I'm going to share it with you right now because this guy, you cannot listen to at 1.5 speed. I couldn't. This guy has got to be listened to at normal speed because, well, he's German, first of all, but the concepts are wonderful, but wow, here we go.
And Steve, will you post these later?
Start on.
Say what?
Will you post these videos to Slack later?
Yeah.
Or email out the links?
Yeah, I can take my little shot.
Got four images for you.
I'm gonna
so look at them.
I can't control this guy.
2.
There we go. Whoop. Control them. Okay, good. I got it controlled. I have a PDF. I've got these notes I took, and I'll put that in a PDF file and send it to you. Okay?
Okay.
Because the links are really cool, and I've got a really cool bonus link in here with the mitochondria. Which was passing off electrons. I could not freaking believe it. A cell gets its energy from electrons on one side of the membrane from the other side of the membrane, and what little mechanisms are created to pass those off freaking blow me away. It's a bonus thing. All right, this is about vectors, and it shows about what goes on inside pi. This is what's happening inside a pi, and the guy is freaking cool. Here we go.
Okay, So to start off, I've got four images for you. So look at them. 1, 2, 3, 4. Now, quick question. What do all of them have in common? Well, I would be really surprised if you guessed this one here.
Oh, they're full of lines.
Huh?
They're full of lines.
They're full of lines, and they're in a circle and these other things. But they're actually pictures of times tables.
That's times tables, you guys.
Pictures of times tables. I better explain this, all right? So to get these pictures, what you do is you start with a circle, and then you pick a random number, okay? And we'll just choose something nice to start with, so 10, okay? So then with 10, we put 10 points on the perimeter here, equally spaced, and then we label them with 1, 2, 3, 4, 5, 6, 7. Okay, let's just go. Actually, we start with 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 we also want. So we kind of put that right there again. So that's also 10, that's also 11, 12, 13, 14, 15, and so on, okay? And then again, and so on, right?
And so
this guy stands
you see the spiral that's happening right there, right? And he has to bring it into itself. Just hang on. Here's where it gets real exciting.
1, 11, 21, 31, and so on, okay? And now we're going to do the 2 times table, okay? So 2 times table, and we'll start with 0. So 2 times 0 is?
0.
So 0 is the same thing, so we don't do anything. Okay, 2 times 1 is?
2.
2, okay, so we connect the 1 to the 2. Then 2 times 2 is?
4.
Okay, so we do this, and we keep on going, pretty obvious. Now 5, 2 times 5 is?
10.
10. 10, remember, 10 is also over there, so we connect that guy up. And then 2 times 6 is 12, which is also the 2, so we connect that one, and you kind of just keep on going like this, okay? And then you're at 9, and you've pretty much gone all the way around. Now you could go on. So for example, we could now do 2 times 10 and 2 times 11 and 2 times 12 and draw in those connections. But actually, the connections are going to be exactly the ones that we've already drawn. We can actually stop here. Just to illustrate, let's just go up to 2. 2 times 12 is?
24.
24, which corresponds to the 4, and that connection's already there, right? And 2 times 13 is?
36.
Not quite.
2 times 13, 26.
26, and we've already got the 6. Of course, we made a choice there at the beginning, that 10, right? If you change that 10 to anything else, well, the picture changes, but pretty much everything I said stays the same, okay? So for example, if you switch from 10 to 11, we get this guy here, you know, and then 12, 13, 14, 15, and let's just see what happens.
So,
pretty nice.
Quick question.
Yeah.
All these pictures that you're showing, it seems that they are symmetric.
Yep.
In the horizontal axis. Like
That's right. Yep.
Is that for a particular reason?
Yep, there's a reason, and actually, let's just give this as homework for our guys here to figure out. So in the comments, tell us why there's a symmetry. Of course, what's much more interesting here is that curve that somehow magically materializes when you kind of
recognize
up the
that
number
shape?
that you choose at the beginning. Okay, and actually, I'll just cover a bit. So there's this strange curve here. It's actually got a name. It pops up all over mathematics. It's called a cardioid. Like in cardiology, it means heart. Okay, so it's like a heart curve, mathematical heart curve. And it comes up in all kinds of places, and I'll just show you a few. Okay, so for example, you can have it as a rolling curve. You roll one circle around another circle, and just see what happens to one of the points on the boundary of the rolling circle. Okay, so for example here. And what it does is it traces the cardioid, okay? Now where else can you see it? Well, sometimes you can see it in your coffee cup. If you've got a conical coffee cup like this, and the sun is in the direction of one of those green lines in the coffee cup, then you can also see a cardioid in there.
I didn't notice this before, you guys, but please notice the coffee cup drawing that he has up here in the corner. Did you guys see that? He has a little coffee cup. He'll show you them again, but he has the coffee cup down here. But then up here is a coffee cup, and you're going to see that again in just a second, okay? And we're almost done with this guy.
In the direction of one of those green lines in the coffee cup, then you can also see a cardioid in there. Where else? Well, there, right there, in the Mandelbrot set. So the biggest Mandelbrot set is cardioid. The second one is actually a perfect circle. Now, be a good one to figure out why is this guy cardioid? And so I'm just going to trace this down somewhere. Now, just for those people who know something about this stuff, that's the equation that we use to make out the Mandelbrot set, and there's a 2. Okay, so that's important. We just had the 2 times table. So let's just keep going. Okay. Now, yeah.
If you want one more thing about the cardioid shape, is actually as a video producer, I know that microphones, there's a category of microphones called cardioid microphones, and that's
I'm
The
gonna
sound is
see if I
very
can
bad.
speed this up. Oh, Brett, pardon me. Oh my gosh, I don't know why my computer is so hard to control.
Would be a good one to
Okay, good.
this would be a good one to figure out why
Okay, I'm gonna go 1.5 times speed now, because now you guys understand.
Now, just for those who know something about this stuff, it's the equation that we use to make up Mandelbrot set, and there's a 2 there. Okay, that's important. We just had the 2 times table. So let's keep going. Okay. Now, yeah.
Now they're talking about what's called a cardioid microphone. A cardioid microphone makes that same shape. There it is in the middle of the little diagram.
Okay, right. Well, we can do another video. Okay, now we can also, instead of doing the 2 times table, we can do the 3 times table. If you do the 3 times table, what we get is this pattern here for initial choice 10, and then I'll just up the numbers there. And what do we get? Ooh, another curve. Another very famous curve. This is called the nephroid, which is a kidney. Okay, whereas this one also has a rolling curve here. The circle that rolls is half the size of the one that's rolling around. It's also in a generalized Mandelbrot set. So remember, before we had an exponent 2 here. Now we're talking about 3 times table. We change the exponent to 3, and you actually get the main bulb here being the nephroid. Okay. We also get it in a coffee cup. This time we need a straight coffee cup, and the light rays kind of come in like from one side. Okay? So they kind of come in straight like this, and then they kind of bounce around inside the cup and make up this curve. Actually, this way of making up a curve is called catacostic in mathematics. So there we go. What else have we got? 4 times. You can kind of see a pattern now. 4 times gets you three petals. Before we had 3 times 2 petals. Okay, and then all these other things that we've kind of been highlighting here. There were 2 there. Exponent's gone up to 4. There's the generalized Mandelbrot set here. Now we've got the rolling curve happening again, right? And then just for good measure, there's one more guy here. There's the 5. That gets 4 petals. And we've got the Mandelbrot set here, and we've got the rolling curve. So all very, very neat. Okay.
So the number of petals is n-1.
Yeah, n-1, and it keeps on going like this. So there's a pattern like this. Okay, so let's just start again with 2. Okay, so that was 2 times table. Now, one really nice thing to try is actually make increments not 1, not to 3, to 4, to 5, but actually do smaller increments. Okay, or actually do the transition here continuously. So let's show you if I just do the multiplication times 2.1, what do you get? 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9, and 3. And you can kind of see how the cardioid turns into this nephroid, which is kind of cool, right? And now I just let it go, and the numbers are going up, and you can see the petals going more and more and more and more, right? So this continuously. And well, you think, well, that's probably what it's going to be. You can also look at this in the Mandelbrot set, and you can actually see exactly this sort of pattern here happening in the middle. And if you kind of push the exponent to infinity, the whole thing kind of turns into one big circle. That's pretty cool. Okay, and that's I think that's the end of it. But no, let's just keep going here. Right? The petals are pretty much going to go away now. But if you just look at what's happening here, you see there's a lot more structure somehow being hinted at, right? I mean, we're moving very fast at the moment, right? We're moving very fast. But if you actually went through this frame by frame, you see a lot of really, really nice structure happening. And I've highlighted a bit here. So just a few of the frames that you get, some really amazing stuff happening here. So if you stop at 33, you get this one here. You stop at 34, you get that one here. And there's a couple of other highlights here. There's a lot more. It's just this is how many I could fit here, right? Okay, and maybe have a close look at some of them, okay? So here we've got 4. Now the number that all these correspond to is actually 200, okay? 200. What we're really doing here has a special name in mathematics, okay? So what we're really doing here is we're doing the times table modulo 200, okay? So it's got a special name. It's actually incredibly important in all sorts of applications to do this sort of modular arithmetic, okay? But anyway, for our purposes, you understand how it's built up, and if you know a little bit more, you know a little bit more. Okay, so for 2 times table, we get the cardioid. For the 34 times table, modulo 200, we get this guy here. And then some other things, interesting things happen. So for example, if you multiply by 51, we get this guy here. And if you multiply by 99, we get that guy here. And obviously, I mean, if you just look at the 2 numbers here below, 51 is pretty close to 1/4 of 200. Must have something to do with that. 99 is pretty close to 1/2 of 200. Must have something to do with that. Right? Okay. Now, I really want to explain something. I really want to explain where this one here comes from. And well, I mean, the first time I saw this, I was pretty surprised, like pretty much everybody sees it. But then I remembered something. I had seen the cardioid before, in many, many different guises. And in one particular one that I was familiar with, I could see where the connection is. And I just want to tell you about that one, okay? And it's got to do with this light rays bouncing around. It's a little bit different from what we had before, okay? So basically we've got a circle here, and then we've got a light source right over on that side, right? and that circle kind of reflects the light, right? So we switch on the light over there, and then, well, what happens? Well, light rays kind of emanate in all kinds of directions, get reflected off the circle, right? Bounce around, and you kind of see this pattern here emerging, the cardioid. Yeah? So I knew this one. I had actually calculated the curve, from this description at some point at university. Okay, then they can actually really see very easily why the cardioid comes up in the 2 times table. And I just want to show you. Okay, so let's just highlight like one of those rays coming out. It kind of hits the wall here. Okay, and then it gets reflected at the same angle as it comes in, right? So this angle here that you see here is the same as there, right? You can see it kind of goes like that. Okay, so what does that tell us now? Well, if we kind of put this line here in the middle, it means that this side really flips over to that side here, which means that this segment here in particular is exactly as long as that one here, right? So if I travel from this light bulb to this point, and then from this point to that point, it's exactly the same distance, okay? So that's going to be important. Okay, so let's make this 0. Let's call this n. So what's 2n then, right? So to get 2n, what you have to do is we have to measure this distance here, and then you have to measure it again. Where do we get? Right up there. Right? And so it's pretty clear that when you do the 2 times thing, you get that reflected ray, in the picture. Just to finish off, I'm going to show you a little bit of a movie of all this stuff evolving a little bit slower than what we had before.
Okay. Okay, so that's Vectorville. Bunch of vectors, and I'm complete. I have more to show you. Maybe I'll just send them to you, and you guys can watch them on your phone.
Steve, you got next week sewn up, mate.
Oh, okay, good. Oh my gosh. I was vectored out.
Stop sharing, but you got next week, mate.
Uh-oh. Uh-oh. And I thought Fred would have a heart attack over the sacred geometry, but he would love this crap. I thought of Fred the whole time. Because this is pure math right here. And what blew me away was we have all these vectors of energy that occur in this circle, which I make up in my mind, and yet there they go in the middle of these Mandelbrot sets. Blew me freaking away. Whoa. Okay, I'm complete.
All right. Well, do you want to stop sharing, and then we'll go around and we'll do a final count?
Okay, very cool.
Okay, so go ahead, Steve. Lead it off.
Let's see here. Do I share now, or I invite somebody?
No, you share last. You sum it all up. It's your.
All right,
Exactly.
Raphael.
No, actually, I feel great. Actually, it's. I find actually my takeaway today is what we are able to construct in our minds. So there's a relationship that happens in universe, but our mind. I mean, it's a bit redundant, but our mind has a mind of its own. But still, we're relating. And we talk about a single point in the beginning of one of the videos. Is that the idea of a single point is just a construct in our mind. In universe, if we look at it, there's always a relationship. There's always something else. And there's always something left over. So I love the concept of our mind working out universe and how we can relate to universe in this geometric construct that doesn't exist in universe, but still is connected to it. So this is just mind-blowing stuff. So thank you, Steve, for sharing. So that's my takeaway. How about you, Manu? How are you feeling, and what's your takeaway?
Well, it is really awesome. I don't know. To me, this is the way math has to be taught. It starts with, and when I come back to what Becky said, is that you can only imagine and think from within your universe. Nobody has ever been outside of his universe. And the leftovers and whatever figure that we have is because it is closed. From within will be a relationship, and those relationships with repetition come to patterns, and those patterns are reflective of the universal laws of harmony of a universe at its stand. And that's what we, in our function, we discover progressively. And my takeaway is that the thought of mathematics has to be rethought. I don't know how you guys started with timetables. We used to rote memorize it. Rote memorize. And that's the way we learn how to count. But you learn how to count by say play. And taking kids, having sets, and maybe having balls of different colors thrown at each other, so that, or having ropes of different colors, creating those relationships, right? You can start seeing stylistic forms that are very hard to imagine if you started otherwise. And that's how you start grasping, really, at very early age, what Fred would call sensorial geometry, you know, a way that is effective for fulfilling whatever we have been put here to do. And that is, you know, experimenting and improving and understanding the whole, even though we just part. And that's what I take from here. I mean, to me, it's mind-blowing, and it's another way of seeing life that I haven't been used to. Susan, how do you feel? What do you take away?
I feel very grateful that the rest of you are also loving sacred geometry. That bug is catching, and I really love that handle, and that's the reason that I got kind of involved with the Resonance Science Foundation, because they were looking at that specifically, and that's what led me back into your group. So I'm loving that. I've got a list of topics for stable datum that I want to that I want to spend a little time with this weekend, and I'll post up to Slack in the glossary. But I think having those terms kind of put out there, and then we can add to the clarity of definition on those terms, because I will tell you that I need to go back and really kind of in my mind clarify Mandelbrot's set. This idea of the microphone, the Cartier's microphone. One of the terms you use all the time, Manu, that I have looked up, but I want to actually write it out so I get it, is degrees of freedom. So there's some different topics that have come up along the way that I feel like if I got clear on those specifics of the terms, it would help me be more clear in understanding how those individual concepts bloom into a relationship that's now spiraling. And I love Bucky because he saw the shapes. I mean, he was about the geometry of thought. Mm-hmm. And when I try to explain why I love Bucky to other people, I that's the term that I use, that he looked at the geometry of thought. And as we go through this, Raphael is so quiet, and yet my heart is just kind of aching to hear more and more how the linguistics play in with this other language of ratios in geometry. And we've kind of moved a little bit away in this last week from digits and numbers, but they're all in that mix and playing. And so I'm really excited to have this progress. And so Manu and Raphael, I also want your input, and always Kelly, just all of you. I just want to put in that space and see from your vantage point. So I'm super grateful. Kelly, what are you thinking? What's your takeaway?
I was fascinated by it. I think it's making the complex complicated. And there's a difference between being complex and complicated. So when you draw that circle, right, and then you take a point, each point is the center. That's what it started in the first video, is the center. And then when the center moves out, it moves out, and we draw these straight lines, and it hits a boundary. Okay, so it moves out. The second it hits the boundary, the only thing it can do is move back in. But it moves in at an angle. So you got your center, and then you have it moving, because it's going inside the boundary, it's actually going out to the boundary of that circle.
Yeah.
Which is another point. And then as soon as it gets to the boundary that we contrive in our mind, it bounces and it goes and hits another boundary in the same circle. But the interesting part for me was that as it went outwards and it hits another point, it now goes inwards. And if you have a look at every one of those drawings, it creates a new center in all of those, not the boundary of the circle itself. And it always appears like the density of it appears like a black hole. So if you go back and you look at those geometric figures, and when you see it bouncing off, and it's bouncing, and it gets that curve. So you've got this outward curve, and you've got this inward curve. And where there's this inward curve, we start to see that, but we still see the outer boundary. But there's this inner core. So if you go back and look at those, in my mind, it's creating these little things like that. So it's not the circles that interest me. What interests me is those cores, those things that it's developing now go into microcosm. So we look at those big heart things, but we don't look at the microcosm. Look at all the microbes that are being developed around those drawings on the Mandelbrot set. So if you look at, you've got the macro, and then you've got the micro, and you've got all of these, I mean, there'd be billions of inward outwards. There's not northeast west. There's inward and outwards and between this and around this. So to me, what they've proved very clearly is you start where you're at and you move out. You get to a boundary and it moves in. And then it's the betweenness between that in and out that starts to create all of that stuff. So we get so caught up in the beauty of it. What about all the microbials of it? Because you could see the microbes. So the thing that I take away from tonight is this idea, and by the way, what Fuller actually said was you never see outside yourself. He said that there is no beingness that's ever seen outside itself. So that's the implication that each one of us is a universe. So we don't see outside ourselves. That's why the center of where we're at is in self. And then as we're moving out, and we move out, we hit a boundary. And when we hit that boundary, just think of the multiplicity of what goes out from that movement outwards. And then as we start to do that, where do we go? I mean, no wonder we think we have infinite possibilities in finite spaces. But we don't really have that many directions. So that's what I take away from tonight. Steve, how do you feel? What do you take away?
Well, I agree with Manu that if I had been shown these charts for math, I think it's great to figure out how many apples I have and how many oranges I have. I think that's really cool. But to understand how math creates these relationships is just mind-boggling to me. And to see all these little vectors coming around these circles and having them all of a sudden appear as the space in a Mandelbrot set completely freaking blew me away. There is so much going on within the boundaries that my mind is boggled. And I'm so excited to share some of this confusion that's going on inside here, some of the amazement that I'm experiencing. I also want to say that I started into lucid dreaming about a couple years ago, and right now, or about 8 months ago, I think is more accurate. And I keep a journal. I have a journal back here. This is my dream journal back here in my desk. And every morning I get up and I log. And one morning, and I don't have that many lucid dreams. In fact, I'm getting so little sleep right now, and I'm so involved in so many exciting projects. I'm doing everything I can to get my 7 or 8 hours of sleep. That I'm not doing as well with lucid dreaming. But there was a time when I was dreaming that in my dream I was explaining something really, really well. Everybody in the room was really getting it. I was teaching this concept, and I'm going, man, the method I'm using for teaching is so powerful. I've got to remember what I'm using here. And so I slowed my dream down and took a look at what was going on. And I could not, when I woke up, all I could see was the golden mean. All I could see was the Fibonacci sequence. I could see squares and rectangles and squares and rectangles and everything fitting together in these squares and rectangles. And I think that thought is bound by these relationships. And I think words are too. But I don't think we get the relationship. And that's what I think part of my book has got to be about. It's got to be about that relationship. So I'm anxious to hear what more develops out of this group, because I'm going to steal a lot of ideas out of here. I'm complete.
And Manu, I like your black hole thinking.
Cool. So I'm complete, and thank you very much.
All right, you're up again next week, Steve.
Okay, I'll share a couple more thoughts. I'll put together this PDF file and send it out by late tonight.
I'll record it.
Did anybody see at the first iteration or the first few one, how would I say, the buttock of a lady?
Oh yeah.
Did you see that?
Yeah, but not only there's a vagina as well. There's that.
Okay, but it was there.
Yeah.
I'm
It
sorry,
just wasn't you,
I did
Manu.
not understand your words, Manu. What did you say? Did
He said,
anybody?
did you see the buttocks
And
of
ladies'
a,
buttocks, yeah.
yeah, the cardioid is a buttocks.
What?
But it's,
I mean,
Exactly.
to me,
could
what
be
it
my-
does.
it could be my
What is
buttocks,
that?
Manu. It doesn't have to be a woman.
Yeah, exactly.
Okay. but what was there was actually the essence of the gestation of bringing, of the process of how will I call it, the
Zygote becoming a fetus?
No. What I was saying is the lopsidedness of matter together and the relationship to the spinal. Are you with me? When Steve started talking about the sun, and the other side, you can imagine the chemical energy in the components of, say, a body or a certain kind of closed volume, and the way precession, actual fact to me, was at action. In other words, creating macro relationships in such a way that it becomes in a big macro organism. Right?
How about it creates division, Manu?
Mm-hmm.
Yes, it is division. Yeah.
Because rather than the buttocks, the beingness buttocks, what you can see is it's the cell division, and what you're seeing at a macro sense is the buttocks. But if you go down to the cell, you'll see the same thing from things that I've seen.
Yeah.
And
But to me,
videos that you were showing, Susan, was all of a sudden it starts to break out. Boom, break out.
And then the center kind of moves. It gets some polarity to it. And what I've seen, Manu, I understand what you're describing, and that pattern, I believe, eventually, in my concept, starts to make this double torus field pattern with the Mobius strip, that central tube that would be running along our chakra, allowing for the energy to flow in and out. So that put those diagrams over each other.
Me too. In fact, I show, when I teach that or when I discuss it with people, just to talk about the miracle, I show each chakra center, energy center, as its own torus. And then they
Right.
work together. They work together. Yeah. And I'll even show a torus on the 4 directions with a Native American medicine wheel. So the north is its own torus and the south is its own torus. I mean, that's just energy center is what it is.
And then when Bucky Talk comes in with vector equilibriums, you've got 2 complementary rotating functions. So you've got the double torus coming together along that axis point.
Yeah. And the word modulo, I don't know if it was hard to anybody to learn about, to study time. You know, in mathematics, when they brought in time and modulo, because time is modulo 24 or modulo 12, right?
Okay.
One cycle is 12. And to count modulo and to determine relationship between modulo, and when you have a modulo that is a multiplier of another modulo, let's say modulo 2 and modulo 4. Modulo 4 is in modulo 2. You get me?
Yes. And again, Manu, it's a construct of the mind.
Yeah.
Yes.
And the sooner we understand that all of the concepts that you're talking about are constructs of the mind, we'll get out of this asinine conversation about minds blowing and mindsets. Our mind does not blow, it does not set, it relates and it interrelates. It's the very function of that. And so when we use words and language, the words and the language, I remember vividly Kiyosaki saying, I make the complex simple. No, he makes the complicated worse. Because he doesn't, you know, you can talk about stable datum, but complex goes to simple. You know, complicated goes to stupid. And what we have to be careful of is when we're using our words and when we see things like we see them, we come from the center of our mind's reality. We never see outside ourselves. That's fundamentally what Fuller's saying. You never see outside yourself.
This graphic right here of these dots going around in all these different directions, which is one depiction of a torus, that is a projection of my mind.
Yes.
The only reason why I'm seeing it that way is because my mind, all perception is a projection. I'm projecting that out there. It's like I'm looking through a screen through my window. Everything is in this little screen and graph because that's who I am. That's who we are.
Yes.
Yeah.
And
marvelous.
And my point is, the second we understand, words are the absolute leading calibrator, without question.
Yeah.
Okay.
Yeah.
Numbers are the lagging. They're the way that you make sense of something. And symbols hold space. So A, B, C, D, E, F, G are symbols which create words.
Sure.
And so you get phi, Y, whatever the hell you want. But they all become mind constructs. And the sooner we get to understand that, then we'll start to realize that we'll get to principles and patterns.
And Kelly,
Cool.
can you back up? Words are leading calibrators?
Calibrators.
They lead. Every word you use leads your mind somewhere.
In Sanskrit, in the Sanskrit language, the actual vibration of the word related to the meaning of the word. And that actually influences the language we're using today. And the further away the vibration of the word gets from the reality that I'm trying to pick out, the more confused I get, the more polarized I get, the more arguments I'm going to have. And finding those words are critical.
Yes.
And I think it's time to go. We'll do some more next week.
All right.
Yeah.
I don't mind getting up this early, but I hate being
Modulo. Modulo.
Yet another word for my stable datum collection.
All right.
See ya.
All right.